one of Utah's foremost poets, and we've all noticed that. He does a couple other things besides poetry. He manages to get his finger in here and there. He's got a master's degree in business administration, which I'm sure was helpful when he became the first director of the University of Utah Research Park a long time ago. He said we didn't have an exact year on that. And I know that he's been head of the Institute for New Energy since about 1993. So he's definitely got a lot of cool things to share with us. So let's go ahead and give a warm welcome to Hal Fox.
Thank you. Is Moray King in the audience? Moray King. Are you here, Moray? Well, at any rate, he's just got his new book out, The Energy Machine of T. Henry Moray. I highly recommend it. Now, let me get this talk started with a little bit of specialty here. In this pair of Levi's is a lesson for us all. Cowboy tough on horseback, but the first one's had a flaw. Tightly woven denim and cleverly stitched double, and riveted at all the stress points to never give us trouble. Cowboy tough on horseback and around the campfire embers, just one rivet problem, right near our private members. Now, a cowboy loves his tools, loves to brag that his are best, but there are private tools about which you don't jest. When you crouch by that fire and then get up to stretch, there's a hot rivet telling you there's a hanging rope to stretch. One cowboy saddled up and said, "I'll find that designer guy. First I'll stomp him in the mud and then I'll walk him dry." Another said, I'll find that guy on my gun, I'll cut a notch. So declared the cowboys, don't put rivets in the crotch. But Levi Strauss was stubborn, a thing that I must mention, and for that suggestion he gave it no attention. But cowboys still liked Levi's because they were hard to rip, so to get their point across, they took Levi on a trip. Levi loved the campfires, and with his denims he crouched near, and the space from the campfire embers to his crotch was mighty clear. And when he got warmed up, he stretched as a cowboy would, and then he got the message, and he got it really good. And that is why today, in this nation and afar, that crotch in your Levi's, there ain't no rivet there. Okay, we talked about UFOs. Let me give you some background. When the time I graduated from college, I had served in World War II, but just as I graduated from college, the Korean War was starting. And I should have gone, they let me stay in and graduate, and as soon as I left, they gave me a commission, and I went into the Air Force. And they trained me to be a meteorologist, a weather guesser. And while I was serving in Germany, by the way, this was a previous contract we had showed that there was a top secret information. So this was top secret. I guess officially still is top secret information. But anyway, when the radar is going out and seeing things that are far away, then the radar is close to the ground. If there's a temperature inversion, in other words, if it warms as it goes aloft instead of cooling as it goes aloft, you'll bend the radar down and pick up a truck on the highway and make it look like it's a strange object up there on the side doing some crazy maneuvers. So they would check with us to see if there was a temperature inversion whenever they an unidentified flying object. And we would then tell them whether there's a temperature inversion or not. If there wasn't, they scrambled the jets and they'd go after those guys. Well, those things could fly circles around us. But I can assure you that there were UFOs, and there still are. Now, thanks to a friend of mine, he's been in contact. By the way, these UFOs cannot travel through from a galaxy to another. These are shuttles from a mothership. The motherships are very big. They'll have several thousand people aboard the mothership. The one that's up there that's over our area, over North America, assigned to North America, is called the Capricorn, and it has about something around 60 shuttles with it. The head of the commander of the Capricorn is a big, tall alien named Helena. And a friend of mine has been communicating for the past, more than a year with Helena. And the information has been put on the internet on www.starshipcapricorn.org. And so you can find the information there. But I wanted to assure you that there are these flying saucers. A friend of mine was in Oak Ridge, Tennessee, and that's a government installation. It has some very highly secret project like it also at Los Alamos. And he took some pictures. Some flying saucer came over and was looking over the area, and they took about a roll and a half of pictures. And very surprisingly, the government let him keep 3 or 4 of them. We'll show him some of the others up there. Okay. So the concept that there are UFOs, there's no question about it. See, there's these streamers coming down. I'm not sure. I think that's the anti-gravity. It's not. They don't blast off with like our rockets do. But I think that's ionizing the air. I think the anti-gravity beams there ionize the air. I'm not certain of that, but that's my concept. So at any rate, the Capricorn has been assigned to North America, and it's been up there now for about 10 years. And the concept is that they will come and land when they're not going to be shot down by the government. The government has a standing order of the Air Force to try to chase and shoot down any of these UFOs that show up. Well, they don't like to come down when they're coming here to show that they're coming in peace. They don't want to be shot at by aircraft. So there will be a change in the orders to the Air Force, and I think it'll occur here relatively soon, in which they will no longer be told to shoot down the UFOs. By the way, when they're sighted in India and in China, there is not this kind of nonsense about they don't exist. They talk about them, publish them, they get pictures once in a while. Apparently there are motherships that are assigned to different parts of the world. Now, the assignment has been given by the Galactic Federation to the starships are to clean up the Earth's atmosphere. We've already lost many plants and animals, and some sensitive humans are suffering because of the high amount of carbon dioxide in our atmosphere from the burning of fossil fuels. So all this nonsense about we don't have enough oil, well, our oil is limited, there's no question about that. But that isn't the real problem. The real problem is that we're getting the atmosphere so clobbered up with extra carbon dioxide that's what we must solve that problem. So that's what we've been working on in our laboratory for several years now to find methods and technology that will help solve the problems of cleaning up the Earth's atmosphere. To do that my talk will be about how we tap into the energy of space and get the energy of space to be able to help in getting new forms of energy. So any questions about the UFOs? By the way, they do not communicate normally by, like what's our biggest means of communication currently? The internet, isn't it? It's marvelous. They think here an earth-girdling, wired-up technology, the internet, they think that is really quite something. They communicate telepathically, by large. Some of the aliens do not even have vocal cords, so they couldn't talk to you, but they communicate telepathically. So that's how LeVar gets his information from Helena. He communicates directly with Helena. Any of you who have telepathic friends, you can have them communicate. They can contact somebody on that starship. It's really quite interesting.
We have a few questions in the audience. Would you like to take a couple right now?
I'm sorry?
We have a few questions in the audience. Would you like to entertain a few at the moment?
Yes. Any questions about this particular part before I get into my regular presentation?
It's on mute.
Yeah, why do they call it the Capricorn if that's our term? Is that our term or is that their term? Why would they call it the Capricorn? Because that's after one of our constellations, that we named.
You'll have to tell me what he said.
Is Starship Capricorn our term or their term?
Oh, that's a good question. In their own language, I'm not sure what they call it, but that's what we've been told is they call the Starship Capricorn.
Yeah, because that's one of our constellations that we named. And so, do they name it after?
I'm so hard of hearing. I have to have somebody tell me what you're asking.
Okay, ask it again.
What?
Okay. Okay. Up here, the acoustics are very poor. We have an echo. So, can you repeat the question, please?
Yeah, Capricorn is the name of one of our constellations, and so why would they be calling it the Capricorn?
What do you say?
Here.
If in fact they really do exist, they may very well have given it a name that is one of our names. See, like everyone knows what Capricorn is, and so that's symbolic. And if they gave it a name, it's very good that they gave it a name that we're familiar with, instead of giving it a name like, guess what, I don't know, but I think it's a good thing if they gave it a name that we're already familiar with.
Okay, the lady right behind him.
Hal,
Hal?
where do they say they're from? Where are they from?
Where is what?
The occupants for Starship Capricorn, where do you think they're from?
There are several different alien races on the Capricorn. Where it actually came from or was made, it's a huge ship. It can't land on a planet. Only the shuttles can land on planets. So I'm not sure exactly where it came from. There's a huge, we'd call it a computer system in the Pleiades, and a friend of mine who is writing a book about what she's received telepathically has been in communication with this big computer in the Pleiades, and that book will be coming out. It's called Moroni Blows His Horn. Any of you who are familiar, on the Mormon temples, there's always an angel Moroni. He's got his horn, and the idea there, the concept is that the second coming of Christ, he'll be blowing his horn. That to say that the second coming. From what I've been told, the person who is the reincarnated Jesus Christ is on board the Capricorn.
Okay, the next question in the back.
Mr. Fox, how does Capricorn keep from being noticed by us? Is there like are they too far out for us to see with our radar, or what? Is there a cloaking device, or how do they keep from being seen?
Okay, how does Capricorn keep from getting observed by our radar and avoid our regular optical and radar detection?
The Capricorn is fairly well out there in space, farther away than our rockets can get to it. In other words, it's out there circulating around Mars or somewhere out in that area. It's a huge ship, and there have been those who have detected where it is, but I can't tell you exactly where it is in at any particular time. However, when the shuttles come for when it is going to announce its presence and let you know it's here, my guess is it'll be up there flashing its lights or something so it can be observed.
Okay, next question.
Hal, I want to know what data you have that indicate these ships are benevolent and not malevolent.
What's that again?
What information do you have that they are benevolent and not malevolent?
Well, that's a good question. The best I can say is that the communication that LeVar's had with them for several years, or for several months, has given all indications that they're here to help, and they'll come down among us. Now, their assignment from the Galactic Federation is that they are not to interfere in anything that the U.S. that the Earth people are doing, unless they are asked to. For example, our laboratory has asked them if they will allocate a couple of their people to come and help us with developing our new energy technology. And so we expect to have 2 of them come to our laboratory after they land, after they make themselves known. What they're doing, a shuttle will land. One will land here at the Salt Lake Airport number 2. It'll be on the ground for maybe 30 minutes or so. They'll open up their hatch. They'll show themselves what they look like, or at least what one part of them. There's several. There's a small Shart aliens, and I think that's when they're going to be aboard the shuttle to land here in Utah. They're landing in several places, and then there'll be flyovers by others. I think as far as I know, there's only 5 or 6 places where they're actually going to land. One of them is going to land in Canada, one in Salt Lake, and I've been asked to get the media, get the media out there to take pictures and so on when they land. And the information of when they land will be on that website, the Starship Capricorn website.
Okay, next question. We have one more question before we go back to Hal's lecture. In the center back there, did we have one? Okay.
All right, we'll get into
Here's Hal. Back to you, Howard. I mean, Hal.
Okay. Okay, does everybody have a copy of my paper? I want to make sure everybody get a copy. If you don't have a copy, raise your hand and we'll get it to you. I like to have fun here. We just chat about this. We don't have. You can read the paper later. All the information is there. So Yuri's handing out copies of the paper. Let's take up the first. Oh, wait. What I want to show you first, though, is what charge clusters look like. And so we brought in this. I've taken some water. If you can see, if you could get close to that, you'll see this water is kind of brackish. In other words, it's going to be a fairly good conductor. As you remove the brackishness of the water and get toward more pure water, the resistance of the water change. You know, pure water has a high resistance. So what I have here is some of this water in this cell, and in this little unit here, there are two zirconium electrodes, and the zirconium conducts electricity, the wires here conduct electricity, but the zirconium oxide layer has a very high resistance. And so the voltage drop that we're going to put across that is going to be a high voltage gradient across that zirconium oxide layer. And then that produces these charge clusters. And the charge clusters consist of a whole bundle of electrons, and we'll get into that more, describing what's behind the charge cluster. But let's see if we can get this to fire up. Okay, I'm coming up. We're going to get up to about 10 amperes here. We're running probably around 150 to 175 volts onto those electrodes. And now you can dim the lights a bit if you want. Turn the lights down.
The output of this into the water is that DC racing?
Yes, it's some polluted water, and we're running the current through through that water, and we have to use alternating current because it has to heal up that burst out zirconium oxide layer. That oxide layer has to be healed up. So you can see it's getting pretty hot there. It's starting to boil that water. Now I'm deliberately letting it run a little while because I want to show you that it doesn't take very long for those charge clusters. Yeah, take pictures if you like. It doesn't take long for those charge clusters to take out the polluted. And if you could come up here, instead of the 10 amps we set up, it's now down to about 2 amps. So the water is becoming more and more. Well, we got to. It's about as much as we can. Whoops, careful. No, don't. Careful, that's hot.
Yep.
No, don't put any water in. I want them to see what. Now, we're going to let that settle out a bit. Here, I've got that off now. No danger. We're going to let this settle so you'll see that in just that few minutes of operating, it has taken a lot of the dissolved material from that polluted water, let's call it, and you'll see that it's made some precipitates. And the fascinating part about it is if you can, some of you who are here close here can see now that you can see the precipitate settling out, and see how clear the water is above there. Yeah. Okay, now the fascinating part of it is that in these precipitates, if you analyze them, chemical analysis, you'll find that the precipitates now contain some materials that were not in the water. In other words, there's some fusion and fission events that are going on in that water.
Could it be coming from the electrodes?
Beg your pardon?
Could it be coming from the electrodes?
No. You can analyze the electrodes very carefully, but there will be some stuff that's from the electrodes.
But it is transmuting. It's transmuting.
It's what?
It is transmuting into something else.
Yes. Now then, we'll go into that a little bit like that. So anyway, there you've seen the charge clusters in action. It's fairly clear water now up there, and you can see this gradually precipitating out. Okay, let's have the first slide that we. The first patent that was issued by the United States that they could get through the United States Patent Office on this charge cluster technology is patent 5018180, and it was by Ken Shoulders. Many of you probably heard of Ken Shoulders, but he's the inventor, the discoverer, has the first patent on, and so here's a case where charge clusters can be formed, and there's a voltage on this end, and the charge clusters are formed here, and this would be low pressure, could be atmospheric, but generally lower pressure. And the charge cluster, as it goes through, travels along there, it'll induce voltage in this winding. The end result is that the power that you can take out here, note that this is just open-ended, this wire. So here this is a coil, and the power you can take out here, according to the patent, has been up to 30 times as much as the energy that you put in to create the charge clusters. Now that's a phenomenal advance. As far as I can tell, this is, as far as I've been able to find out, this is the first patent to make this claim that, I think this is what it says, we're not sure of the source of the excess energy, but we believe it comes from tapping the energy of space. If you could take all the energy in space everywhere, including inside of us, inside of your own body and outside of our own body, if you could take the energy that was in just that amount, space everywhere, out in outer space, and turn it into thermal energy, you could boil the Atlantic Ocean. Now, why don't we feel that energy? Because it's the same inside as it is outside. If you want to feel that energy, then what you do is get in your car, fasten your seat belts, accelerate to 50 miles an hour and slam on the brakes. And what happens to you? Well, you're thrown forward in that seat belt. We've labeled that as inertia for a couple of hundred years, and only until recently has Hal Puthoff and his friends been able to show that any mass as it accelerates picks up space energy. When it decelerates, it has to give it up. And so that's the source of our inertia. And that's enormous amount of energy that's everywhere present is what is flying those spaceships, those shuttles around. They're picking up space energy. And it's space energy that we want to develop, and this kind of space energy that we want to use to change the way the world produces and distributes energy. Now, the other inventor wasn't able to get the invention. The late Stan Gleason was the one who discovered the charge clusters in liquids, and we've been working for several years with this technology that Stan Gleason invented or discovered. And we found the more we play around with this charge cluster technology, here we have a source here where the charge clusters can be used to create additional energy. Also, the charge clusters can be used to clean up brackish water, seawater. We have a group who they asked for a proposal from us, and we gave them a proposal for $5 million to be able to build big enough equipment so they could take seawater and change it into agricultural grade water. One of the things we've been working the most on, though, is using water that had radioactive thorium in it. And the same thing happens here. The thorium is, let's see, well, we'll get to that. What's the next slide I've got there? That's, okay, here are charge clusters that form. Note that how can such a lot of electrons be stable? That's the real big question. Well, the concept is that these electrons, at least we've been able to solve the problems mathematically of that if these electrons are circulating around the outside of this toroid, then they make a strong magnetic field on the inside of the toroid, and the end result is you can have a stable cluster of some 90 million or whatever number of electrons there are there. Now, if you create that charge cluster in an atmosphere, it will ionize. For example, it'll ionize. Say you had water vapor, just for an example. It would ionize and attract or just take hydrogen. Hydrogen has the way we view hydrogen, it has a nucleus, a proton surrounded with electron. So this being highly electrical, highly negative, it'll drive the electron away from that hydrogen atom, and the protons then can collect around, attracted to, and collect around this charge cluster. Well, now we've got a kind of an interesting situation. We've got a highly negative toroid here, and it's got a lot of protons to it. So what we've got is a poor man's proton accelerator. Because if you have the target material here at about 5,000 volts, you'll be able to get enough acceleration of those protons that you can begin to change or to transmute some elements at just 5,000 volts. At 100,000 volts, you can transmute about any element. Now, at Los Alamos, the government has spent about $2 billion to make a proton accelerator, and the end result is that, by the way, the protons are known to be able to transmute radioactive materials, and so they spent a whole lot of money to develop a proton accelerator to be able to bombard radioactive materials from like the spent fuel pellets from the nuclear power plants. Well, the reason that they don't use this proton accelerator they developed at Los Alamos is because it's too expensive. It's cheaper to take the radioactive materials and bury them in Yucca Mountain for 10,000 years. So what we're saying here is now we got a poor man's proton accelerator. We're proposing that be used to handle those, to change or to transmute those radioactive elements in the spent fuel pellets. So the next slide there, if you've forgotten what I got next. Oh, here shows the evidence. If you need to scoot that up, we need to show both ends here. This shows how much radioactivity we started with, and then this is what we had after like we did here, where we started with thorium, and then we had a large amount. We reduced it by about 70% or more. Now, the contract that the grant that we're getting, the grant is for taking radioactive materials and stabilizing them on site. And the first grant we've got is for stabilizing radioactive liquids. That's why we've been doing our work with the charge clusters and liquids. So the concept is we're getting a $40 million grant to build a truck-trailer combination that can go up to where there are radioactive liquids. And by the way, there are about 150-something sites in the United States where they've got these radioactive liquids. And the only proposal is that they kind of package them up and seal them up and then send them and store them in Yucca Mountain. So our proposal is we'll go right up there and we'll suck up the material and we'll run it through 2 or 3 or 4, whatever necessary, sequences so that we reduce, each time we reduce it more until we've got the radioactivity down to where it could be used for agricultural grade water. And that way we'll clean up the radioactive wastes on site. So that's what our grant is for to accomplish. Thank you. Okay, here shows the charge cluster being emitted from the electrode. And what really happens, though, instead of getting just we get these charge clusters like this, but they're only about around 20 microns. Correction, they're only about they range from 1/2 to 3 microns in size. Why no other size ranges, we don't know. From 1/2 to 3 microns. 24 microns to 1,000th of an inch, is that correct? So these are relatively small. Next slide. They don't stay like that. They come out, you make a bunch of them, and then they order themselves into a circle of charge clusters, and I think with alternate polarities. And that row of charge clusters then travels like a smoke ring does. In other words, the charge cluster is in a plane here, and it travels perpendicular to the plane. Normally, the charge clusters are about in that range of about 1,000th of an inch. Now, with more energy, you can get larger charge clusters, larger rings of charge clusters, and that's been demonstrated. By the way, the charge clusters have been found by about 4 different scientists independently. This figure shows that if I've got a material here that the charge cluster can clobber into, and then let's say this is a heavy element, and the protons get into that element, instead of that element being maybe somewhat radioactive and splitting into other elements, when additional 1 or more proton gets into the nuclei of that radioactive material, it becomes immediately radioactive, or I should say, excuse me, it becomes immediately unstable and splits up into 2 additional elements. And we get elements clear across from about iron up to some of the heavier elements. Below about iron, these always have, they're larger than iron, let's just put it that way. But not as large, of course, as the element that we're working on. We're working with thorium, and the elements, of course, are uranium and the plutonium elements that are in the radioactive liquids and in the spent fuel pellets. Okay, next slide there. Whatever I had next, I've forgotten. Oh, was that it?
Yeah, that's it.
Oh, okay, all right. All right, let's get down to our paper here. Now you've got a little background here. There's not very often that a new technology comes along that you can expect to develop into $1 trillion a year technology. We believe that this charge cluster technology will develop and grow into $1 trillion a year industry. One, it can produce energy cheaply. It can also take radioactive materials and reduce them to non-radioactive materials. It can be used for a variety of purposes. However, it's going to take several years. It'll probably take a decade for us to get to where this is widespread technology. The major application of this technology that we're working with is to replace the burning of fossil fuels that are polluting our atmosphere. And here we tap into the energy of space itself, provide direct electrical energy to be used in your homes, in your automobiles. I've got an electric pickup truck. That's going to be our hangar queen. Y'all know what a hangar queen is? Okay, that's the airplane that you do all your work on, but it doesn't really go out and fly very much. Anyway, that pickup is going to be our hangar queen for having an onboard battery on the vehicle, battery charger for this electric vehicle. So in a few years, I think we're going to see many, many more electrical vehicles out there. And in fact, we believe that the charge cluster technology can be used to practically eliminate the batteries in a battery car. In other words, you get a big enough unit, size of a bread box, about is what we kind of guess should be able to operate. You'll still have some batteries to get things up and running, but then the electricity and the power to run our cars will be from tapping right into the energy of space itself. The technology had been independently discovered by Ken Shoulders, by the late Stan Gleason, who worked with the liquids, and also by Alexander Ilyanok in Belarus, by Mesyats and Barabushkin in Russia, and then apparently by Oleg Grishkevich in Vladivostok, Russia. And so these charge clusters can be produced in low pressure gases in the atmosphere and in liquids under special conditions. And that of course is what our talk here is about. By the way, in our laboratory, we, soon after Pons and Fleischmann demonstrated cold fusion, we developed that we did that in our laboratory. In fact, that's what got our laboratory started. I was so fascinated by having such a wonderful invention or discovery that we set up in our laboratory and set up and replicated their work. And then I got scratching my head and said, here we're using high-priced electricity, and what are we getting out? We're getting out relatively low energy, thermal energy. That's not going to be the answer. That's not going to change the way the world produces and distributes energy. So I began a search. In fact, during my search, I've gone to Russia or Belarus 13 times and to find technology. And we identified about 4 different technologies that appear to have the potential to really do something. And this one, this with the charge cluster technology is we have acquired the rights. There's about 6 patents issued now. We've acquired the exclusive rights to this technology, and we're working with that. And the money that we supposed to have been getting about 2 years ago apparently is being released within the next couple of weeks. In other words, early in August, we should have the funds by which we can really start going great guns at developing this technology. So it's and by the way, there were 16 PhDs in MIT that did some cold fusion work, and unfortunately they found out they got some excess heat. So they went back and changed their data, and that's why Gene Maloff, who had the MIT job of handling scientific communications, he resigned because of these people that would actually go ahead and change their data to show that cold fusion didn't exist. So that was a kind of an interesting work. Okay, well, Ken Shoulders was one of the first people to discover and patent this technology. And he was by his patent attorney. He said, Ken, as soon as you put that patent, as soon as that patent hits that patent office and they have a good look at it, they're going to classify it secret. Are you familiar with it? The government does. This is the only country in the world where they can take your idea, classify it secret, and not let you use it. So they decided, okay, we'll put in the mail the patent application. But before we do, Ken Shoulders wrote up all of his information in this book. And as soon as they put the patent application in the mail, they put the book in the mail to some of his friends in about 25 different countries. Well, as soon as that patent application hit the patent office, within a couple of days they called up and said, this is being classified secret. I said, but we've sent this information out. You know, if you publish information before you file your patent, then the patent will not be issued. But we sent this book out after we've filed for the patent application. They said, get us the addresses. Well, unfortunately, the computer had eaten up the address list. That was too bad. It was too bad it happened that way. But so that is why today in this nation and afar we can talk about this technology. Okay, Stan Gleason discovered the effects of water, and he found out that he could reduce some of the radioactivity with what he was doing. Unfortunately, Stan Gleason died. He applied for a patent, but they wouldn't issue him a patent. Real interesting. He couldn't get a patent on what he did because they didn't believe he knew what he was doing. So anyway, we've solved some of the problems of understanding the charge cluster itself. We can show mathematically that it does have to be a toroid. We don't know yet, we haven't solved the problem yet, why the range from a 0.5 micron up to 3 microns. We haven't solved that problem. If any of you people have some real good ideas about that, we'd appreciate it. Okay, now Alexander Ilyanuk in Russia described similar discoveries he made, and he found that you go 20 microns, but you also go to 50 microns. And there's some evidence that there's 140 microns, but Ken Shoulders tried making this second level with more energy, and it wiped out transistors in his scope, and it wasn't even hooked to the experiment. He says, "I'm not working with it. My equipment's too expensive." And then the next discovery was done by Meschatz, working with Barabushkin, and then Meschatz wrote and presented a paper in California at the 15th International Symposium on Discharges and Electrical Insulation and Vacuum. This is the one that Shoulders calls the Arcs and Sparks Conference. And it was some disappointment to Meschatz to find out that Shoulders, who was present at that meeting, had already made a similar discovery and had applied for patents for it. In October of 2001, there was another Russian scientist came out with a statement of his hydromagnetic dynamo. He said it is also known that the dynamo uses high-density charge clusters. Unlike hot fusion and fission reactors, the hydromagnetic dynamo does not accumulate any radioactive components. Well, so we think the high-density charge clusters are thought by some theorists to be the reason that didn't produce the radioactive materials. Okay, the current work that we're doing. We're able to produce both thermal energy and electrical energy with this charge cluster technology. In other words, as I showed you, our aim currently now is to develop the technology where we can get 10 times as much energy out as we put in. The patent shows it can be done for somewhere around. He uses an example in the patent that is 30 times as much. Okay, and we can create nuclear reactions. We think that it's going to be involved in other new energy discoveries. In fact, I give all the references here, the papers that you. There's these high density, by the way, Shoulders called them EVs for electron validum, which means strong electrons. And, but EV stands for electric vehicles, so we chose to use HDCC for high density charge clusters. They can be used for a variety of liquids, salt water, seawater, water from hot springs. This is the water from hot spring. And you can see now that that's the precipitates down there. If you want, do you want to pass that around or so people can take a look at it? Just don't spill it on. It's not hot now, but you'll see the water is quite clear.
Let's just not confuse looking at it versus wearing it.
Okay, all right. Let's see. Okay, Here are some of the following things that we think the HDC production can be used to accomplish. In the processing of aluminum sheet to greatly increase the surface areas. In other words, if you have they like to have lots of little spots and so on in aluminum sheet, so they use it as a capacitor. It has much more surface area. We think that's one of the applications for the charge cluster technology. There's a fellow by the name of Pap, and he had, I think that he was leaning over his engine and this special engine he was working with, and we think maybe the neutron emissions from charge clusters he was making was what caused his early demise. So we have to, the over-unit effects of the patent by Korea and Korea, we think are due to charge clusters. They don't like to think that because the charge cluster technology would interfere with their patent application. Greneau has found that by using plasma discharge to accelerate water jets, he's getting some additional extra energy, and we're quite sure that's due to the charge cluster technology. And there's many new effects discovered as cold fusion experimenters have produced underwater arcing. These voltages are increased in electrochemical cells, and there's many other references could be cited. The discoveries of Yamaguchi where new energy gases are obtained from underwater arcing. We're quite sure that what they're getting is the gases are coming from elements that are being produced by charge clusters. Okay, so what's the future work for all of this? We think that the multiple independent discovery of these high-density charge clusters is one of the greatest scientific discoveries of the 20th century. And the ability to tap energy from tapping the zero-point energy of space itself is just going to be a marvelous new addition into the way we produce and distribute energy. And then I've stated here in the paper that in a quart-size volume, you get enough energy, you could boil the Atlantic Ocean. Okay, so here's what we kind of expect, the last part of my paper here. The commercialization of these devices for the production of thermal and electrical energy, the development of electrical systems to be installed in electric vehicles, and the commercialization of methods of producing scarce elements from more plentiful elements. Now this is pretty interesting. We have found in the analysis that we've been able to afford to have done, we're finding it's unusual. We have some unusual elements that are being produced. And the production of agricultural grade water from seawater or from brackish water. For example, along our Wasatch Mountains here, there's several of these hot water springs, and that water has to be disposed of in some fashion. And so here we have a technology where we think that it can be economically treated, and with the precipitates we get, we think we speculate that we'll be able to get enough funds from the selling of the precipitates, the things that are in the precipitates, there'll be enough valuable elements in there to pay for the cost of the production. And the same with, there's a real problem with some oil wells. They get a lot of water coming from the oil wells, and that's a problem in getting rid of that water. So hopefully we'll be able to provide on-site activity near the oil well. They can take that polluted water and they'll just have fresh water that can easily be disposed of, and then we'll keep the precipitates, or at least we'll, and hopefully we'll be able to provide that kind of a service at a very low cost to the oil wells. So that's my story. So any questions you have, I'll be glad to try to answer them if I've got any time left.
Okay, we have a little bit of time left, Hal. Larry has the microphone here. Uh,
Got a
We have a question
right
down
here.
front.
Are you familiar with Blacklight Power?
And with who?
Blacklight Power, Randall Mills. Randall
Oh,
Mills and
yes,
Blacklight Power.
yes. He's asking if we're familiar with Randall Mills' work, Blacklight Power. Yes. Randall Mills has done, I think, a remarkable job, and I think that his Blacklight Power will be a fact. I think if I'm not mistaken, I've cited that in the reference in here. And yeah, and so that's another place I think that I think he's going to make some differences and help the world by his discovery.
This is not a question, Hal, right here, but an observation on your last statement. I live near a place called the Black Mountain Disposal. I get anywhere from 10 to 20 trucks going one way, only on one road. That means there's probably 40 trucks go to that disposal area, and they're disposing this water you're talking about. This is water, but it's not radioactive. It's well water from drilling. So your device is good. I've thought about trying to talk to you about using your device to get rid of that water.
Thank you.
Brown's gas also transmutes nuclear waste. Is there a similar connection? I mean, is the electrolysis and the passing of electrons, is it similar to the charged clusters?
I'm not sure. Brown's gas has been used to show that he can handle some nuclear waste. We think this is considerably in advance of what can be done with the Brown's gas technology. But it certainly deserves, these various things deserve more, funding. We're very pleased to be able to have received or been approved for a $40 million grant. It's pretty hard to get. By the way, that fund is not coming from the government. The government, I don't think you'd have a chance in Hades of getting funding for this technology from the government. It's coming from a company called Planetary Association for Clean Energy. That's Dr. Andrew McCrowski's organization, but he set up a separate limited liability partnership called CEPA to bring in these funds, and he's getting something of the order of, well, considerably more than the $40 million that we're getting. He is funding some other activities as well, and he's been promised these funds now for 2 years, but it does appear that the funds will be available this coming month. I got a call from him this past week, and he said he expected to have his funds to us during the first week of August, I hope. My wife is running out of funds to support me in the
Hal, could you repeat that demonstration?
I'm sorry, say.
Could you repeat the demonstration?
Oh, repeat the demonstration? Oh, I guess I could.
I think we'll need the, do you have a second container, Hal?
We have to get the.
Okay, I think we'll need the container back
jar
if we're going to
back.
repeat the demonstration. Larry,
How's our
could
time?
you bring that down center?
How's our time running?
I think we've got almost exactly enough time to repeat the demonstration.
Okay, all right.
I have a question.
Yeah, Hal, I think if we expedite, we'll have just exactly enough time.
Where am I going to get? Is there a sink back there? Oh, okay. There's a couple of those.
Here, start with that one.
Can I trade you? Next one. Don't drink this at home, kiddies.
Okay.
Thank you, sir. Oh, we have more questions? If we could hold him for just a moment while Hal's preparing the demonstration.
I just, no, just a minute, Okay, I just, no, whoop, not that low. It goes too far. They're pretty sensitive to. Okay, you don't turn off the lights if you want. Okay, we'll see if we can fire that up.
Okay, just as it gets started, we're going to turn the lights
Okay,
all
we're
the way
up on
off.
5 amperes, 6, 7, 8, 9. Anybody want to come up and take pictures, go ahead. I think this is an incredible new development in terms of technology discoveries, and I'm sure glad that the guys that went their patent through, I'm glad that patent attorney had sufficient smarts to make sure it didn't get classified. That would have been terrible. We've tried some of the Great Salt Lake water on this. And
What did you say the electrodes were made out of?
zirconium. And interestingly enough, Western Zirconium has a plant west of Ogden, Utah. And they've been working with us and furnishing the zirconium. We expect to be a user of some
Okay, Hal, we got time for one more question. I guess there was one in the back there. Go ahead.
They're used for the rods in nuclear power plants. And the reason they use zirconium, the fuel pellets are put in the zirconium tubes. But when the uranium splits into smaller elements, it throws out neutrons. But the neutrons are going too fast to cause the other uranium particles to fission. They have to slow them down. So the zirconium is to replace the burning of oil so that we reduce the amount of carbon dioxide that's poured out into our atmosphere. If we don't, we'll all be dead for too long.
Okay, thank you very much, Hal. Anyone else wishing to field a personal question? Hal will be down front for about 5